Okay, so we have learned how to identify functions. So if we've got a function, then now we're going to learn how to compare functions. So let's look at this problem here. Today was a snow day, and Felicia decided to track the snowfall. So we're already 2 inches on the ground. And though she measured it every hour, and she found that exactly 1.5 inches fell every hour. So if it snowed at this rate for 5 hours, how much snow is on the ground at the end of each hour? So you can fill in the table. So initially, there were already 2 inches on the ground. So for time 0, we put 2. Then every hour it snowed 1.5 inches, 1.5. So after the first hour, there's 1.5 inches plus that you already had 2. So that's 3.5. Then you add a 1.5 to that, you get 5, and so on and so forth. So we have an initial value here of 2 inches, and then a rate of change, a rate each hour of 1.5 inches. Now, can we turn this into an equation? Well, yes. Alright, so if we're going to make this like an input-output table, and we've got X up here and Y. Okay, so we have an initial value right here of 2. Okay, and then every time X goes up by 1, we're adding 1.5. Well, what if I wanted to know how much this would be for 20 hours? Well, I'm not going to want to go ahead and fill in this chart all the way up to 20. So let's think about what's happening here. So I'm adding 1.5 here, but how would I do this as an equation? So what is happening every hour, which is my X? Okay, it's got a rate of 1.5. So if I wanted to know what it was after 20 hours, I would take that 20 and multiply it by 1.5, and then add my initial value, which was a 2. So my equation is Y equals the rate, which is 1.5, times how many hours I have, which is X. And then I add what I started with initially. And now I have an equation. Okay? We can also graph things. So this is this equation graph. Notice here at X equals 0, which in this case was time, I start my graph at 2. This was my initial value. So this is my initial, here it is, initial value right here at 2. Then my rate for every hour, I went up 1.5. So at 1 hour, I'm right here at 2, I go up 1.5. For my next hour from here, I went up 1.5. The half plus 1 got us up to here. For the next hour, 1.5, and so on. Okay, so I'm going up and over for my rate of change. So we could look at a graph and find our rate of change looking at the difference in the X's and the difference in the Y's. Okay, my rate of change is going to be my vertical change divided by my horizontal change. We'll see that again. Alright, so let's look here. Another example. If I have this biologist, 2 different trees to growth over a 5-year period. This is my silver maple here. It says here, it doesn't explain this, it just says here's my graph for my silver maple. Then she tells you about the red maple, and it's starting diameter 4 and an average growth rate or rate of change of 0.3 inches every year. Okay, how can we compare these two? Well, we need to do something with the red maple so we can compare it to the silver maple. So I can start making a table. So it has an initial value of 4, and then every year it's going to go up 0.3 until we fill in the table. Now you can compare from here to here, or we can go ahead and graph it, is what they did here for you. And notice it starts at 4, and then it's going to go up 0.3, 0.3, 0.3, and so on. Now, how do we compare these two? Well, let's look at it. The silver maple didn't start at 4. It looks like it started at 3. So how much did it go up each year? Now to figure out this rate of change, since this, we can't really see this very well, so we find points that we know. So we know this point here. This point here is at 0, 3, right? Now this one I'm not real sure where that is, but this one is on 4. So this is out to 4, so this is a 2, 4 is another point that I know. So I can find the rate of change by looking at the difference in the y. So it went from 3 up to 4. So that's a difference of 1 in the y. It went from 0 to 2 in my x. Okay, so it's the difference in your y and then difference in your x, and you're dividing those. Alright, so what is my rate of change? It's a half, which is 0.5. So this one, the red, was 0.3, but my silver is 0.5. So my silver is growing more than my red each year. Now, does that make sense? Let's look back at the graphs. They both seem to end up right here at 6 after 6 years. Close to 6 after 6 years. This is about the same place. Close to 6 after 6 years. So there's the same size after 6 years as it looks like on this graph. But this one started at 3 and it grew up to 6. This one started at 4 and grew up to 6. So yes, it makes sense that this silver maple is growing a little faster than the red maple. And that's what we figured. This rate of change was 0.3. It was given to us. This we determined from the graph was 0.5. Alright, so here's what I want you to try. It's an easier problem. Just pause the video and see if you can figure this out. It has no initial value. This is actually easier than what we just did. The table graph shows how much money a store earns selling each team t-shirt and each team cap. Compare the rates of change for these two functions. So this is your t-shirt, this is your cap. Just compare the rates of change for the table and the rate of change for the function. So pause this video and figure that out and have the answers for class tomorrow.